So I just thought of something. This is going to open up a whole new time, right? When we look out, we see the past. Is that true?
Well, we see things as they were in the past if they're far away. Look, I'm seeing you in the past right now.
Right.
It's taking some time for your signal to get to me,
Yeah.
but light travels so fast, and electric signals and wires and waves travel so fast that it looks like it's instantaneous. But my now is not your now. I just said now, but when I just said now, you heard it a little while after I said it.
So, okay. So now you're looking. So when we, first of all, let me ask you this: is time travel possible? Do you think it's possible? Is it like theoretically possible?
Well, yeah, I wrote about this a lot in the physics of Star Trek, but the, uh, the the laws of physics do not forbid the possibility of time travel,
Wow.
but they also suggest that it's highly unlikely.
Yeah.
That in order to the general relativity allows for the possibility of time travel, but in order to do that, you have to create configurations of mass and energy that are strange beyond belief. And many physicists think there are probably laws of physics of quantum mechanics that say that you can't really create those conditions. So while time travel is theoretically not impossible, uh, the kind of configurations you'd need to create a time machine are so extreme and weird that it's quite likely that they're not achievable.
Can you sort of theorize what that would entail, or no? Is that so?
Well, I mean, again, I read the physics of Star Trek. I give an example of a wormhole. A wormhole, if it existed, which is a shortcut through space, would give if you could have a stable wormhole, you could build a time machine.
So how,
And,
have we
what?
ever discovered a wormhole? Is that even a
No,
thing?
no, we don't know if they exist.
Uh,
Again, stable wormholes don't exist unless you have exotic forms of energy that are totally different than anything we've ever seen or heard. But but if you could create a wormhole of the type that Jodie Foster went through in Contact, um, then she could literally do she could come out the wormhole and come back and be younger than she was when she left.
Now, in the movie with McConaughey,
Yeah, Matthew McConaughey. Yeah,
what's that movie called?
Contact.
Yeah, no, I'm thinking of the one where he goes into into a wormhole.
Oh, Interstellar.
Interstellar, yes, yeah.
Yeah, one of the worst movies ever made. Yeah.
Coming from a theoretical physicist, I should take your word for that. So that's completely nonsense. That couldn't even.
Uh-huh.
They did no.
Well,
They do
some
any,
things are nonsense. My friend Kip Thorne, who later won the Nobel Prize, helped design the images of the black hole around the star because that's kind of a fun thing to do. But most of the movie is just complete scientific nonsense.
right. So a black hole is not the same thing as a wormhole.
Oh, absolutely not. Well, hold on.
Okay.
We don't know what happens at the center of a black hole. We don't know what happens at the singularity. Maybe it's a tunnel to another universe or another region of the universe. The only problem is you wouldn't survive the journey. So
Yeah.
you'd be stretched into spaghetti and torn apart when you got close to the singularity by the tidal forces of gravity.
Now, I always thought about this because the black hole, it stretches you out, right? But if you were to get put back into the shape that you were in before you went into the black hole, would you theoretically be back to life again? Or is
Well, I mean, you're asking me if I took apart your body into the individual atoms and I put them all together back in the same way, would you be you? And the answer is maybe, and that's the transporter
there you
in
go.
Star Trek. And we'd be great to do the experiment. The problem is the laws of quantum mechanics say that I can't really do that because I can never know where every atom is in your body and what it's doing at precisely the same time because of the laws of the Heisenberg uncertainty principle, and therefore I can make an approximation of you, but I'm not sure it would have the same memories or thoughts.
Yeah, because you hear about people talking about, like Elon Musk says this, like it might be possible one day to download your consciousness into a computer. It's like, okay, let's say I did that. Let's say this is all true, right?
Mm-hmm.
And I download my consciousness into a computer, but I still go on living. My physical body, I'm still alive. I go on living and I die. And I have no idea what my simulation version of me in the computer is doing. So is that even really pointless? Is there even a point to that? Or am
Well,
I
it
just giving
depends. I
life
mean,
to another?
but your simulation feels like you. So I guess you can kind of feel like some. I mean, people constantly want remnants of themselves to persist past their death, and that's one way, I suppose. Another way is writing books, I guess. But
Yeah,
um, and so I think that you know, I don't know what people's motivations would be, but the idea is interesting because um, um, you know, you can imagine lots of it's all science fiction, right? If I could download your consciousness, then if you got sick and maybe you could, you know, in some problem, they could do something, and then maybe you could upload the consciousness back and be yourself again. All sorts of, you know,
right.
strange and possible
It
things.
makes you wonder. So if that's like if that's possible, first of
It
all,
isn't possible now, but yeah.
right? If so, who would be there to monitor this computer with everyone in it? And then eventually, when people have to get off the planet, because climate change is inevitable, the world's not going to stay here forever. It's not going to. Eventually, we have to get off this planet. Then what? Do they take the computer with them, and or they just
Why should they go? Just send the computer.
right? There you go. There's a solution.
No,
Right?
I mean, I seriously, the only kind of interstellar travel that makes sense to me is to have microscopic robots that encode intelligence, and if you wish, can build biological beings on the new planet. But I don't. I think the idea of sending 200 pounds of bags of water into space to colonize the universe seems ridiculously ridiculous because we evolved to survive in this environment we're in now. We're not very good up there.
Yeah, and that's another question. Is like uh, astronauts when they go into space, they start. It seems like they rapidly start to evolve, and they start to lose their bone density and stuff like that.
Some things like bone density get smaller, although it's recovered quickly when they're back in the gravitational environment. You know, and of course, unlike the protected environment around Earth, when you're in even interplanetary space, you'll die from the radiation. So it's not a good place to be.
Yeah, and then back to time travel for a second. If time travel really was possible, I don't know. I mean, wouldn't someone already have came back by now? Or unless we're just the beginning,
Well,
it just happened to be the beginning of
when I
everything.
talk when I talked about time travel, I used to have Stephen Hawking wrote the foreword for that book, The Physics of Star Trek, and he used to say time travel is impossible because if it were possible, we'd already be inundated by tourists from the future. And
Exactly.
as I like to say, I countered him by saying, no, they all went back to the 1960s and no one noticed.
That makes sense. That's great. Now, so if now is time travel more possible one way than the other? Is it more
It's
possible?
definitely possible. We're doing it right now.
That's true. This video is going to be eternal. We're going to be
Not
eternally.
going to be eternal, but we're moving forward. I just went from the last second to this one. I have been time traveling the entire time you've been
Oh,
talking to me. I'm time traveling. I'm moving forward in time. So moving forward in time is incredibly easy.
yeah. What
You
about
just don't have
speeding
to
it up
do
though?
anything. So if you asked if you know it's easier in one direction than another, it's certainly a lot easier to move forward.
What
Backward
about,
is the problem.
what about moving forward faster?
You make time move faster. Well, you know what Einstein once said when explaining relativity. He said, "If you're sitting on a hot stove, a second can seem like an hour, but if you're talking to an attractive woman, an hour can seem like a second."
There you go. That's a really good answer, actually. Is
It's
it
Einstein's. You can thank him.
that's relativity right there,
Yeah.
right? So I had a question I was going to say. I forgot what it was though. But so yeah, okay. So let's say, let me ask you this: how long do you think this planet has left before we have to get off this planet?
I don't know. I mean, I know in the long term, I know that in 5 billion years, the sun will grow into a red giant, and the Earth will be inside the outside of the sun,
So we have some time.
unless we move the Earth, which is possible.
Really?
Um, but yeah, sure, it's possible to move the Earth. So I know that's going to happen, and in about 5 billion years, also the Andromeda Galaxy will collide with the Milky Way galaxy. Now that won't cause as much. In general, it won't cause a lot of problems because stars are so far apart, you won't really notice anything. But the nature of our galaxy will change. But how long life on Earth? Well, in 2 billion years, there'll be a runaway greenhouse effect on Earth no matter what we do. Not the kind of greenhouse we see, but the kind of greenhouse that produced Venus, because the sun will be 15% hotter and water will begin to evaporate, and it's a big greenhouse of gas. and you'll eventually get the Earth. The temperature of the Earth will be something like 1,000 degrees, something like the surface of Venus. So it won't be very hospitable then. So certainly in 2 to 5 billion years, the Earth is not going to be a place you want to be in, at least where it is. Um, but beyond that, I don't know. And I always say I don't make predictions that are less than a few billion years in the future because first, no one will be around to check them, and secondly, it's a lot easier.